All right, welcome again, guys, to G Squared Academy. We simplify for you. That is just what we do. We just simplify for you. You know what I mean? Because we just want people to understand how to interpret things, how to do their content, to progress. Because success is the aim of our game. Now, in a previous video, I looked at interpretation of graphs. All right. Sorry, not interpretation of graphs. I looked at plotting graphs. It was a very long video, to be honest, but it was necessary because I wanted people to see the steps involved in plotting a graph, what your examiner will be looking for, etc., etc. Okay, very important. Check that video out. It will help you in plotting your graphs if you think you have a difficulty with that. If you have a problem with graphs, there's a specific area in graphs that you'd want me to look at, let me know. Leave a comment in the comment section, and then I'll get back to you on that. All right, today now what I want to do is I want to look at the interpretation of graphs, as you can see on the screen. I'm looking at the interpretation of graphs. What do graphs mean really? When you see a line or you see a curve. And having said that, I'm going to be limiting the interpretations to graphs that we would mostly see in the sciences. Not going to be looking at bar charts or bar graphs, whatever you'd prefer to call them. Just line graphs mostly. Okay, so those are the ones that I'm going to be looking at and the interpretation of those. So, what are graphs really? Graphs really is just comparing two things, usually two things. You can compare more things, but it's always easier to compare two variables. You're comparing x to y. So you're asking yourself, if I increase x, what happens to y? And if I increase y, what happens to x? How do these two things affect each other? And pretty much that's what graphs are about, looking at how two variables affect each other. Now, your examiner wants you to know how to get information from a graph and look at graphs and give trends. And that's what I'm going to be looking at today. So the first type of graph that we're going to be looking at is our directly proportional graph or directly proportional graph. There you go. There it is right there. Now I've only placed in my y-axis factor and variable and my x-axis variable, as you can see from the cursor there, and my plotted points. I'm not really getting into all the other things about the graph because I've already done that in a video. All I'm looking at today is really how do I interpret this? What does this graph mean? I see this in an exam, sir, this looks crazy. What does this really mean? Now, it says here it's directly proportional. So all this really means is that as the value on the y increases, the value on the x increases. That's all it really means. Okay, so as the two things are comparing increase, as one increase, the other increases as well. Okay, it doesn't matter what those two things are. Once they're directly proportional to each other, as one increases, the other increases. Nothing else to it, really. And you can clearly see that from the direction of the graph there. All right. Now, the next one we want to look at, sorry, before we even get there, and of course, this is a force versus extension of our spring situation. We're doing physics. The heavier the weight you're adding, the longer the spring extends up to its elastic limit, of course. But before you get to the elastic limit, the more weight you put on the spring, the longer the spring is going to extend. Pretty much like what you're seeing in this graph. So a force versus extension of a spring graph. You're expecting to see those sort of things. All right, now we move on. Our next graph. Now these graphs are directly proportional, but only up to a point. They're directly proportional, but only up to a point. So there you have your graph. Okay, now I've labeled this because this has to do with those sort of relationships. Your limiting factor relationships for the bio people who are watching this video. When you look at your biographs for photosynthesis, for example, the factors which affect the rate of photosynthesis, right? You're going to find that you're initially, let's say you're looking at adding the volume of concentration or increasing the volume of concentration, and you're saying, okay, if I change the volume of the carbon dioxide, I said concentration, oh my god. Anyway, if you're changing the volume of carbon dioxide, how does this affect the rate of the reaction? As you can see here, when you increase the volume of the carbon dioxide, the rate increases as well. Okay, see, because the numbers are going up. Of course, you know that. But then there comes a point where it doesn't matter if you increase the volume of the carbon dioxide. I keep saying concentration, forgive my guilt. If you increase the concentration of the carbon dioxide or the volume of the carbon dioxide, then what will happen is the rate doesn't change at all. You have reached a point where changing the volume of the CO2 does not change or affect the rate of the reaction, which is why we call these things limiting factors. Okay, so this is what that graph really means. This graph really means you have a direct proportional relationship up to a point where changing one variable doesn't affect the other anymore. Okay, found in limiting factor relationships. All right, I hope you guys are understanding this so far. Now we're going to move on. We have our direct then inverse. So we have directly proportional first, then it becomes inversely proportional. So let me say again, directly proportional first, then it becomes inversely proportional. So there you go, a graph which looks like that. As you can see in the beginning, and let us just say this is a diminishing returns type of graph. Okay, let's say you're doing a titration and you're adding HCl from a burette to a conical flask. Inside the conical flask, you have a thermometer checking the temperature. So as you add HCl, the temperature is going to be increasing and increasing and increasing and increasing until you get to a point where the HCl doesn't increase, the temperature doesn't increase anymore. You're still adding HCl, but the temperature does not increase. So you plateau at that point in time. So this part from down here to up here is where you have your direct proportional. As you would add one, the other one increases as well. But then it plateaus. And then from the plateau, the temperature starts falling, as you can see here. So it now becomes inversely proportional, which we're going to look at soon. Okay, it then becomes inversely proportional. All right, so you have a direct proportional relationship, you get to a plateau, then one variable is increasing while the other one is decreasing, which is what we call inverse. Okay, diminishing returns. Even though you're adding something, it's not helping. You're actually going in the reverse. All right, next is our inversely proportional. Speak of the devil. We have the inversely proportional. Okay, so here you have a graph of energy versus wavelength. So for your inversely proportional, all that happens here is as one variable increases, in this case, the x-axis variable is increasing from 0 to 1,000. The y-axis variable is decreasing. So as one variable increases, the other one decreases. Okay. So this is an inverse relationship. You will find this for physics, chemistry, of course, also, and biology, all the sciences. If you increase the wavelength of the wave, then the energy of the wave decreases. Okay, so this is an inverse proportional relationship. You're increasing one variable, and while you increase that variable, other variable decreases. Pretty much it. That's pretty much it right there. Okay, then now we can have inverse proportionality and up to a point. There you go. Inverse proportionality up to a point. You can find things like this in rates of reactions, in the rate of the reaction. So notice down here that I have the concentration of the product and not necessarily concentration of the reactant. All right, for the people who are chemists here. All right, so what you have happening here now really is as one variable increases, which is the concentration of the product, then the other variable decreases. In this case, it's the rate of the reaction. Okay, so as the concentration of the product increases, the rate of the reaction decreases. The reasons for that we're not going to get into as much as I would love to, but the reasons for that we're not going to get into. Remember, we're just looking at what the graphs mean. We're not looking at the reasons for the graphs necessarily, but just what they mean right now. Okay, so it's inversely proportional, going along nicely, and then it stops being inversely proportional. One variable is increasing, which is the x variable in this case, but the y variable is remaining constant. All right, constant at that point in time. So that's your inversely proportional up to a point. All right, and that's pretty much it. However, there's one more thing that I want to show you, my viewers and subscribers. One more thing that I want to show you, and I'm going to use the directly proportional graph to do it. Now, in your exam generally or in your studies, you will be asked to interpolate and extrapolate. You will be asked to find data from a graph. Now, using this graph, and we have to use an example, using this graph, you may be asked to find the extension of the spring, which is on the y-axis, when a force of 6, see 6 right there, when a force of 6 newtons is applied. Now, how do you do that? Very straightforward. You draw your line up from 6 newtons, go all the way up to where it meets the line, the best fit line, and then you take your ruler and you draw a line across. Wherever that intersects or intersects um, the y-axis, that is the value that you're looking for. Okay, so let me say that again. You draw a line up from 6 newtons, go across to the y-axis. Where it meets the y-axis, that is where your answer is going to be. So we call this interpolation because they asked you for 6 newtons, which is within the ambit of the graph. Is within the ambit of the graph. So it's interpolate. All right. Then now they may ask you, what if the spring was extended 7.5 meters, 7.5 centimeters, since we're using centimeters? What force would cause it to expand to stretch to that point? So you find 7.5 on this axis, which is your y-axis. You draw a line across, and then boom, you go down there. Wherever this line which goes down meets the x-axis, that is your force. As simple as that. Very straightforward. Now, you may be asked to extrapolate or predict a certain force, or a certain centimeter stretch that you may be asked to find. So they may say to you, okay, if you apply a force of 12 newtons, which is over here in the right corner, what extension of the spring are you expecting? What extension of the spring? Now, notice 12 is not one of the values on the graph line. So you might be asking yourself, oh, on God's green earth, do they expect us to find this? However, all you need to do is take your ruler and draw some hash lines, go right across there. Hash lines. So keep it straight and draw your hash lines, go right across there. Right? Then now you take your ruler again and draw a line from 12 all the way up to where it meets the projected hash line. Then from there you go right across and you can then predict. It's not an accurate thing necessarily. Okay, so it's a prediction. You're predicting. So then you can predict by drawing your line from over here, go all the way across to over here, and that's wherever it meets the y-axis, that would be the spring extension that you're expecting to have. And it's the same thing for the extension. They may ask you for an extension. What would you expect the force would cause an extension of 25 centimeters be? Same thing again. You draw your graph right across, and you find 25. You draw your line across with your ruler, go right across, and then you go down to the x-axis, and wherever it meets the x-axis, that would be the force that would cause or is predicted to cause such an extension of the spring. All right. So that is it pretty much. That is it pretty much. How you interpret your graphs, how you interpolate, how you extrapolate information from your graph. Okay. I hope you guys found this helpful. Please like, share, subscribe to my channel, G Squared Academy, where you know excellence is epitomized and you know that things will be simplified for you. Enjoy plotting your graphs, enjoy interpreting them, and I hope you found this helpful. All the best, and I'll see you next time.